Okay guys, I'm going to have you watch this video on factoring, and then hopefully tomorrow when we come in class we can go right into trying this on your own at the board. So you can see I put a little picture of myself up here. Here I am, so that you know that it's really me. Hopefully you can recognize my voice. And this is me in probably one of my, I probably just finished a golf tournament. Maybe I won it, who knows. But there I am right there. So what we're going to learn about is factoring, and factoring, like I talked about a little bit in class today, is the process of expressing polynomials as a product of prime factors. So we want to turn something like a sum into a product. So you can see something like, here's a sum of a polynomial, which you guys are all pretty familiar with. That's a sum. We want to try to make these things into a product. So let's begin. Oops. I'll erase that right there, what I meant to do, and this is new with this. So here I am. Okay, let's begin. So the first thing we want to do is always look to take out the greatest common factor when you're factoring. So here, I'll make this a little bit bigger here. We're going to try this thing first right here. Okay, so we're going to factor this. So what I'm going to look for is the greatest common factor in this term. And I can see that the greatest common factor here, greatest common factor, is going to be 5 of 5, because 5 goes into 5, 15, and 20. And then I can see I can take an x out. That's going to be 1. That's, well, let's see how many. There's x, 2 x's there, 3 and 3. So I can take at least 2 out. And then we got y squared y and y squared, so I can take at least 1 y out. So there it is. I found my greatest common factor. So now I'm going to make this into a product. And since I'm making it into a product, I'm going to put parentheses, because we all know that that means times. So I'm going to pull out the parentheses, and I'm going to try to figure out what exactly I need to put inside here. 5x squared y times what will equal this original polynomial. So I can see 5x squared y into the first term there of the polynomial would be, I need an x, because x squared times x, you add the exponents, is x cubed. And what times what is y squared? Well, we need a y. And there, bingo, we got it. So we got 5x squared y times xy is, in fact, this first term right here. You can see that's the first term. Okay, so then next thing I'm going to do is I'm going to put a plus here. And because I know it's going to be, this is a positive term, this middle term here. And it looks like I can take out, I can make it a 3, because 5 times 3 is 15. 5, and then x squared times what is x cubed? Well, geez, I need 1x. And then y, we're all set, because y and times 1 is y. So 3x times 1, which we just write as 3x. Then I got another plus here, and now I'm on my last term. 5 into 20 is 4 times. And x squared and x squared, we're bingo, we're all set there. That goes in perfectly. And then it looks like I need one more y, and there we have it. There it is, right there. Right there, we're ready, good to go. There is, we have this term times this. So we actually have changed 1, 2, 3 terms into 2 terms. This big package here is one term, all in the parentheses. So this times that is in fact that. And we have factored that polynomial. Now let's move down to this one. I bet you guys could all do this one pretty easily. Down here, now we're going down here. And we are going to look at this thing. I'll make it a little bit bigger for you, okay? And I want to get rid of this this arrow here. We don't really need that anymore. Okay, so we'll bring that down here. You can see I'm still watching here. Here I am in the corner. Okay, so now what we're going to do is take out a, looks like we can take out a 2 as the greatest common factor, and maybe just 1x, because I got 1 here, 2 there, and 3 there. Good to go. Now, it's always good. Do you see this negative here? Right here, you see this little negative thing? We don't like that negative sign, so I'm going to pull it out. It usually helps if you pull it out. So we're going to take out actually a negative 2x, because then it will make this bigger term in here that we're multiplying not positive, with a leading coefficient that's positive. So we're going to put a 9 in here, because I know that 2 times 9 is 18, and we need 2 more x's. Then we're good to go, because in fact 9x squared times negative 2x is negative 18x cubed. Now I'm going to have to do, even though that says positive, I'm going to make this a negative, because I know that a negative times a negative will be that positive 10x right here, right there. That's what I want to do. So I'm going to put a 5 and an x, because I know that 5x times negative 2x, I'll do it over here, you can see, is in fact negative negative 5x times negative 2x is in fact 10x squared, which is my middle term there. Perfect. Then I'm going to put another minus because we need the minus times the minus, and that'll just be 1 because negative 2x times negative 1 is in fact 2x, and we're good to go. And we've factored that one out. We've pulled out the greatest common factor and factored it out. Now it's a product. Those two multiplied together will in fact be equal to that. Now I'm going to move on. Doesn't seem to be happening here. Okay. And now I'm going to do these ones here for you. Let's make this one, oops, let's erase that. Sorry, I'm kind of learning how to do this. So we're going to make this one a little bit bigger. So now this right here is the same thing. Now this one, you might say to yourself, geez, how many terms does this one have? But I can see that this has 2 terms. You see, there's actually only 2 terms here, so there's only 2 things that might be in common. In this case, it's a big package that's common. You see this x plus 5 and that x plus 5. So I'm going to actually factor out an x plus 5. That whole package, we're going to take it out. Okay, and it's going to be times, I'm going to make little big brackets just because so you can really see that there's a difference here. And I can, if I take an x plus 5 out of this first term right here, this first term, whoops, this first term right here, well, right there, see? I'm going to pull that, there's the first term. I took an x plus 5 out there. I'm left with, I need a 6, that's all. 6 times x plus 5 is that, and then we need a plus in here. And what can we take out of here? Well, geez, I took out the x plus 5, so we need 5z would be left over there. And there it is, good to go. That plus that is, in fact, that. Now, here we go. I'm going to try this one. Oh, look who's joining us. Some of you know him, but maybe you'll recognize him. There's Cooper. He seems to be running through our factoring problem. Oh, there he goes. Okay, so now we are going to try this one right here. And I bet you guys could all see this one, what this one's going to do. I'll try to make it bigger here. Let's see if we can not get rid of this thing here. We can move this arrow. We'll just click it off there. Okay. So now this one, again, this is only 2 terms. It's this one and this one, because these 2 are multiplied together. So what's common to both? Oh, well, we can take out the whole package. We can take out that 3x minus 9. And then 3x minus 9 times what is this? And sure enough, it's 5c, because if you take, hang on a minute, if you take this term right here, and you multiply by that, you'll in fact get this big term right here. Okay, so then we're going to do plus, and I can take out, and then it would be a 4, and there we have it. 3x minus times 5c plus 4 is now a product. Those 2 together will in fact equal those. Okay. Now, what we're going to do is factor by grouping, and it's a technique that used to factor polynomials with more than 3 terms. So here, at this first one here, you can see I have 4 terms here. So what I'm going to do is try to group them together and factor out something that might be common to just a couple of them. So first thing I'm going to do is I'm going to look at these first 2 terms here. You might get this wrong and then have to try again. So I'm going to look at these 2 terms here. I got the 5xy and the 20x. What's common to them? Well, geez, a 5 and an x. All right, and then just out of those 2, I would be y, because that would give me the 5xy plus 4. And that, in fact, would be the first 2 terms multiplied together. Okay, then I'm going to slide over here. Keep that positive there, so we're doing positive. And now what's common to these last 2 terms here? I'm going to erase these so we don't get confused. So what's common to these 2 is I can take out a 7, and it looks like a z is common. So then we would do y plus 4. Oh, what do you know? Look at that. Now we have a y plus, now we have 2 terms now. 2 terms. And we went from 4 terms to 2 terms. So now what's common to both these is a y plus 4. So I put that around. I know I'm about to make it a huge product, so I take that out. And what is common to there is 5x, because y plus 4 times 5x is in fact that term, plus, if I took a y plus 4 out of this term, I'm left with 7z. And now this whole thing is all factored into this one product right here. And we did that by grouping. Okay, so we factored by grouping. Now here's another one. We're going to try to factor this one by grouping. I'm going to look at these first two, whoops, I'm going to look at these first two terms. There's 4 terms so far here. There's 2 here. I'm going to look at these 2 right here. And from these 2 terms, I can see I can take out an 8. And so then that would be x minus 2. All right, so I took that one out. And then on these 2 terms, I'm going to keep that minus, the same thing there. And I'm going to take out a y. Okay, now it gets a little tricky because I actually took out a negative y. So negative y times what is negative xy? Well, just an x, because then you can see that if you multiply these together, these 2 together, I in fact will get that right there. Now this is getting a little messy, so we're going to erase some of these marks that I've made. Okay, so then I am going to minus y times what is 2y. Now we need that to be positive, so I need a negative times a negative to be positive, and we'll make that a 2. And look at that. And since those 2 would multiply to be that, now I have only 2 terms. You see 1 term here and 1 term there. So now I've made 4 terms into 2 terms. So what's common to both these 2 terms, and I bet you guys can see that's what's common to both those terms, is an x minus 2. So now I'm going to take an x minus 2 out, and we get an 8 there. And we take an x minus 2 out of this term here, and we get a y. And there we've done it. We've factored it by grouping. Hooray.